This video covers detecting multicollinearity in OLS models. Today we're going to use the General Social Survey from 2006. Once I pull in the data, I'm going to use this data to examine the relationship between income, education, number of earners in the family, health, and gender. In particular, I would like to know what the effect of education is on the household income in 2006. So first I'm going to start by examining my main variables of interest. First, this reports the respondents' genders, and you can see that slightly more females answered the survey in 2006 than males. It's fairly close. And then this reports the health status of the respondent. Earners is the number of household income earners in 2006, and the range is from 0 members of the household to 6 members of the household, when on average it's closer to 1. Then this reports the respondent's highest degree of education. And then finally, the household income in 2006. So first, to examine the effect of the highest degree earned on household income in 2006, I'm going to run a simple bivariate regression of income 06 on degree. We can see that education increases household income in 2006. So having a higher degree of education increases the income of the household in 2006, and this effect is statistically significant at over a 99% confidence level. So even after controlling for the gender of the respondent, the number of earners in family, and the health of the respondent, education still has a positive and statistically significant effect on household income in 2006. The respondent, being female, has a negative effect on income in 2006. This is statistically significant at conventional levels. Since we know that most households have approximately 1 earner, this seems to suggest that having a female as the sole earner of the household decreases the income over having males. And then earners has a positive and statistically significant effect on income. And health has actually a negative and statistically significant effect on income in 2006. If we go back to the coding of health, we can see that positive health is a lower ranking, and then poor levels of health are actually coded as higher values. So this inverse relationship makes sense, theoretically. So next we're going to examine what happens when we include other highly correlated measures of education. So in this model, we've also included years of schooling and this collapsed measure of education, which collapses education into 3 basic categories. The highest category is a higher level of education, and the lowest category is the lowest level of education. So this would seem to suggest, again, this positive coefficient, that education, has a positive effect on household income in 2006. But in this case, the effect of education is not statistically significant at conventional levels. Now, Multicollinearity, so long as it's not perfectly collinear, on its own doesn't bias the estimates of the coefficients. However, it does inflate the standard errors, which decrease the t-statistics. So under extreme cases, this can lead to false negatives. So we fail to reject the null hypothesis that there is no statistically significant effect of education on income, when in fact there is a statistically significant effect of education on income. So one of the common signs that there may be an issue with multicollinearity is that you have t-tests for some of the individual slopes are non-significant, even though the overall f-test of all the slopes is statistically significant. Another sign is that the coefficients vary from model to model, and that the correlations among predictors of variables are quite large. So we can see that there may be some issue with multicollinearity. So to try to detect this further, you can start by looking at correlations in the raw data. And as we suspect, years of schooling and degree earned has a positive correlation. It's quite high, as does education and degree earned. And our collapsed education variable is highly correlated with years of schooling as well. So we can see that these variables are highly correlated. So again, this supports that there may be some issues with multicollinearity in this model. So we can also look at the variance-covariance matrix of fitted coefficients. Now the problem with looking at the covariance-variance matrix of these fitted coefficients is that they're not scaled, so the results are hard to interpret. You can scale them by looking at VC, correlation. And again, this reports the estimates from the fitted coefficients, so not from the raw data. And what you can see happening is often things that are positively correlated in the raw data, such as years of schooling and degree earned, will be then negative when using the fitted coefficients, and vice versa. So health and degree earned had a negative relationship in the raw data, and we can see in the using the fitted coefficients, this is positive. Anytime the results from this are close to about 0.5, we may have some issues with multicollinearity. And so again, we can see that our education variables are fairly close to 0.5 in absolute value, which suggests that there may be issues with multicollinearity. So one of the more commonly used tests to detect for multicollinearity is reporting the variance inflation factor. So the variance inflation factor for the kth term, or kth predictor, is equal to 1 over 1 minus r squared sub k. And the r squared in this case comes from the model which regresses our kth predictor on all the other predictors. So in this case, our kth predictor is sex, and and the value is 1, which means that there's no correlation between sex and all the other remaining predictor variables. And so hence the variance, of beta k is not inflated at all. As a standard rule, the VIF values that are greater than 4 are usually considered problematic, and we should examine further. If the VIF values are greater than 10, suggests that there may be a serious issue with multicollinearity. So if the VIF is 4, so this means with the VIF of around 4, the standard errors are being inflated by around a factor of 2. So we can begin to correct this by removing one by one predictors with VIF values that are greater than 4. So our first VIF value that's greater than 4 is degree. So if I remove this from the model, and see that years of schooling still has a positive and statistically significant effect on income for the household in 2006. And now we see that education not only has a positive effect, but that it is statistically significant at conventional levels. And if we report our VIFs from this model, you can see that they're all under 4, which is fairly good. If we wanted to, we could probably remove education as well and just leave in our years of schooling measure, and our VIF statistics would be even lower.